Hello students, let's see the oxo acids of halogen. So among halogen, F forms fluorine. Fluorine forms only one oxo acid. One oxo acid is possible for fluorine, that is HOF. So HOF is hypofluorous acid or fluoric 1 acid. So HOF or hypofluorous acid, that is the only one oxo acid of fluorine. So one oxo acid of fluorine that is possible, that is an important question, which is the one oxo acid formed by fluorine. And why there is only one oxo acid? We know fluorine is having high electronegativity and small size. So these are the two main reasons of this. That is, fluorine is having high electronegativity. The most electronegative element is fluorine and it is having small size. So due to these two reasons, fluorine form only one oxo acid. So that one oxo acid of fluorine is HOF, that is hypofluorous acid. And all the other halogen atoms, all the other halogens form different oxo acids. So let's see the oxo acids of chlorine. So there are 4 oxo acids of chlorine, 4 important oxo acids. They are HClO4, HClO3, HClO2, HClO. Otherwise we can write like this: HOClO3, HOClO2, HOClO, HOCl. So I think it is easy to remember in this way: HClO4, HClO3, HClO2, HClO. So HClO4, that is perchloric acid, then HClO3 is chloric acid, HClO2 chlorous acid, HClO hypochlorous acid. So these names can be remembered in knowing the oxidation state of this chlorine. That is, if it is perchloric acid, the oxidation number of or oxidation state of chlorine is +7. If it is chloric acid, it is having +5 oxidation state, and in this case, that is chlorous, it will be +3, and this will be in +1 oxidation state. So if you are finding out the oxidation state of chlorine, we will see 7, 5, 3, 1. So according to the oxidation state of chlorine, we can remember these names also. So perchloric acid or perhalic acid, if it is chlorine, it is perchloric acid. So commonly we can say it is perhalic acid. So any halogen we can name in that way, perhalic acid. So this perchloric acid or perhalic acid, in that case the halogen is having +7 oxidation state. So likewise, by knowing the oxidation state, we can name all these acids. So perchloric acid is having +7 oxidation state with chlorine. Chloric acid is having +5 oxidation state with chlorine. Chlorous, it is +3. Hypochlorous, it will be +1. So 7, 5, 3, 1. That is the oxidation states of chlorine in these case of oxo acids. Now let's see the structure of oxo acids of chlorine. So first of all, we should know the skeletal structure. The skeletal structure, that is, if it is chlorine, it will be like this. So this is the skeletal structure. So by knowing the skeletal structure, we can easily draw all the structures of oxo acids of chlorine. So this is the skeletal structure. So with this structure, we can draw all the structures. So first of all, let's see HClO4 or HOClO3. So HOClO3. So first of all, we will draw the skeletal structure like this, and we know OH will go together, so this will be OH, then Cl is already drawn, then 3 oxygen atoms, it will be double bonded with chlorine. So this is the first structure, HClO4 or HOClO3, HOClO3. So HClO4. So first of all, draw the skeletal structure, then single bond with OH, OH will go together, and then the rest of oxygen with double bond. So that is the first structure. Then comes the second structure, that is chloric acid, HClO3 or HOClO2. So HOClO2. So here also we will draw the skeletal structure. So OH will be here, then Cl is already drawn, then 2 oxygen atoms. So 2 oxygen atoms and 1 double bond is converted to a lone pair. So this will be the structure of chloric acid. Now let's see the next structure, chlorous acid, HClO2. So we can draw the skeletal structure, HClO2 or HOClO. So HOCl, then comes O. So we can convert these double bonds into 2 lone pairs. So this will be the structure of chlorous acid. Then HClO. So it will be HOCl. So HOCl. So all these double bonds are converted to lone pairs, or else we can draw like this also. So ClOH. So this will be the structure of HOCl. So this is about the structure of Oxo acids of chlorine. Now let's see some questions. First one is, arrange the acids in the oxidizing power, HClO, HClO2, HClO3, HClO4. So oxidizing power means it oxidizes others. So oxidizing others, that means it reduces itself. That means it accepts electrons. So if it is having more tendency to accept electrons, we can say that this oxidizing power is more. Its oxidizing power is more. So we will see the oxidation state of chlorine in all these cases. In the case of HClO4, we have already seen it is +7. Here it is +5. It is +3. It is +1. So 1, 3, 5 and 7. So these are the positive oxidation states of all these acids. And HClO4, it is having +7 oxidation state. That is, the maximum oxidation state is with HClO4. So oxidizing power is more in the case of HClO4. So HClO4, here it is having +7 oxidation state. So more or maximum positive oxidation state, that means the oxidizing power is more. Oxidizing power is more. So oxidizing power means that reduce itself or it accepts electrons. That means it is having more tendency to accept electrons. So when we are finding out the oxidation states of all these cases, we can see the maximum positive oxidation state is with HClO4. So it is having the maximum oxidizing power. So maximum positive oxidation state, that means it is having oxidizing power. It is having more oxidizing power. So in this way we can answer this question. Then comes another question, that is the pKa value. The pKa value of HClO and HClO2. So HClO and HClO2. So in this case also we can find out the oxidation state. Here it is +1 and here it is +3. So it is -2, this is +1, -2, +1. So this is +1, this is +3. So this is having maximum oxidation state. So this is having maximum oxidation state. So maximum oxidation state means maximum oxidation state. That means more tendency to accept electrons. So maximum oxidation state means it is having more tendency to accept electrons. That means it will act as a Lewis acid. So Lewis acid will accept electrons. You know, Lewis acid will accept electrons. So which is having maximum oxidation state in this case? The second one, that is HClO2. This is having maximum oxidation state. So more tendency to accept electron in this case, and it acts as a Lewis acid. So this is the better Lewis acid. This is the better Lewis acid, and this will be the strong acid. So this is strong acid and this is weak acid. So comparing the acidity of these two, this will be the strong acid and this will be the weak acid. So this is the Lewis acid. This is having more tendency to accept electrons according to the oxidation state. So this is strong acid and this is weak acid. So the pKa value, that is opposite. So the pKa value is more in this case and less in this case. So pKa value, if stronger the acid, pKa value will be less. So pKa value and acidity will be inversely proportional. So this is having less pKa value and this is having more pKa value, or we can say this is strong acid and this is weak acid. So by comparing the oxidation state of these two acids, we can say which is having more pKa value. So this is about Oxo acids of halogen.